Hi everyone. The question is a relation R on a set is symmetric if option A AB belongs to R implies AA belongs to R. Option B AB belongs to R implies BA belongs to R. Option C AA to R for all A. Option D no condition. Okay. As per the definition, for all AB belongs to A. For all Hi students, the question is a relation or an set is symmetric if option A AB belongs to R implies AA belongs to R. Option B AB belongs to R implies BA belongs to R. Option C AA belongs to R for all A. Option D no condition. Okay, so you should remember the definition of symmetry. What it says, for all AB belongs to A, if AB belongs to R, implies the ulta BA also belongs to R, then R is symmetric. Correct? One best example I can give. A and B both are boys. A is brother of B. Then B is also brother of A. Correct? That's what's there in image. You can check that one out. Okay? If A and B are boys, A is brother of B, then B is also brother of A. Correct? So this relation is symmetric. Okay? So to be symmetric, for all AB belongs to A, AB belongs to R implies BA belongs to R. So option B, AB belongs to R implies BA belongs to R is the correct answer. Thank you. Hi students. If R is antisymmetric and AB belongs to R and BA belongs to R, then you need to check the options. A is equal to B. Option B, A not equal to B. Option C, AA belongs to R. Option D, none of these. Okay. By definition of antisymmetric, for all AB belongs to A, AB belongs to R, and BA belongs to R. These two should be there in R. That implies if A is equal to B, then R is antisymmetric. Antisymmetric. Okay. So that is the definition. It's direct definition based question. So AB belongs to R and BA belongs to R. Both pairs should be there in R. Then if A is equal to B, then the function is antisymmetric. Okay, got it right? Along with, actually you cannot directly say along with the ABBA symmetric condition, but similar to that one, AB belongs to R and BA also belongs to R. Then A must be equal to B2 to be antisymmetric. So option A is equal to B is the correct answer. Got it right? Thank you. Hi students, let us take the question. If F and G are invertible, then G composition F inverse equals option A, F inverse composition G inverse, option B, G inverse composition F inverse, option C, F composition G, option D, composition F. Okay, so the proof is not there in your syllabus. You just remember the result. Decomposition F inverse exists only when decomposition F is both 1, 1 and on 2, or if it is bijective, then only it exists. Okay, and decomposition F is or equal to, first you have to take F inverse. F inverse composition, F inverse comp G inverse. Okay, first the second element you need to take and take inverse composition. Now first element inverse. So G composition F inverse is equal to F composition, F inverse composition G inverse. So check the options. So option A, F inverse composition G inverse is the correct answer. Remember the result, very important result. Okay, thank you. Hi students, take the question. Let f from n to n be defined by f of n is equal to n plus 1, then f is. You need to check 1, 1 on 2 or bijective. Okay. So the first method to prove bijective is you have to take f of x1 is equal to f of x2 and prove x1 is equal to x2. So the second method is contrapositive method, means you have to take x1 not equal to x2 and prove f of x1 is not equal to f of x2. This is contrapositive of this statement. It's contrapositive of this statement. You can use any one method. Certain cases you have to use this contrapositive method also. So let me take the contrapositive in this. Okay. F of n is defined as f of n is equal to n plus 1. Let me take n1 not equal to n2. So suppose let me take 1 not equal to 2. Then you check f of 1. If it is not equal to f of 2, then that is correct. What is f of 1? F of 1 is equal to 2. What is f of 2? It is 3. Therefore, f of 1 is not equal to f of 2. Therefore, f is 1, 1. Got it? By using contrapositive method, you have proved f is 1, 1. Now, check whether f is onto or not. So, f of n is equal to n plus 1 and f of 1 is starts with 2. F of 1 starts with 2. So, in range, you don't find 1. 1 is not image of any of the elements of the domain. Therefore, f is not onto. To disprove, if you take one element and show, that is enough. So, since 1 does not have any pre-image, it is not onto. Therefore, check the options. It is 1, 1 only, onto only, bijective, neither. So, f is 1, 1 only. It is not onto. Got it right? Just by taking one example, you had proved f is not onto. And for 1, 1, you have used contrapositive method. Got it right? Thank you.